right, everyone. Get ready, because today we're diving into something pretty cool.
Yeah, we're going to try to crack the code on relationships.
And now, no, I don't mean the it's complicated kind of
We're
relationship.
talking about the fascinating connections between, like, how far someone travels and how much they spend on a trip.
It's interesting to think about, right?
What's really interesting, though, is that we can actually measure these relationships.
We can.
Yeah, with a statistical tool called simple regression analysis.
So it's not just like throwing darts in the dark and hoping we hit something.
No, not at all.
They have actual data we can use.
Exactly.
So we've got this simple regression analysis thing, but what are we actually trying to figure out?
Okay, so imagine this. A travel company comes to us and says, we think people who travel further tend to spend more, but we don't know for sure.
Okay, that makes sense.
And they ask us, can you help us figure that out?
So that's where simple regression comes in,
Exactly.
to see if that hunch is right.
It helps us uncover if there's truly a link between, in this case, distance traveled and the money spent, and then how strong that link actually is.
Okay, so we're talking about patterns, connections, maybe even predictions here.
Yeah.
This is cool. But how do we even begin to untangle this web of data? Where do we start?
It all starts with choosing the right variables, kind of like picking the right ingredients for what we want to make.
Okay.
In our travel company example, distance traveled would be what we call the independent variable, the potential influencer,
Okay.
and the amount spent on the trip, that's our dependent variable, the thing we're trying to predict or understand.
Independent, dependent. So it's like choosing the right ingredients for a recipe. You can't just throw anything in a bowl and hope for the best.
You got it. And just like a good chef checks their ingredients before baking, we need to make sure our data is reliable and ready for analysis.
Ah, okay.
We run a series of checks, making sure our data isn't skewed or hiding any patterns that could throw off our results.
So those are our quality control measures. I like it. What are we looking for?
One of the first things we check is for linearity.
Linearity.
Yeah, we want to see if the relationship between our variables generally forms a straight line when plotted on a graph.
Okay, so we're talking scatter plots, trend lines, all that fun visual stuff.
Exactly.
Gotcha. What else?
We also need to make sure we're working with a random sample of data.
Right, because if our travel company only gave us information from, like, luxury travelers, we wouldn't get a real picture of what's going on.
Right. We need a good representation of all types of travelers, from budget backpackers to those first-class flyers.
It's all about balance.
Exactly.
Yeah.
We also check for something called autocorrelation,
Autocorrelation.
which just means making sure our data points are independent of each other.
So each data point should stand on its own 2 feet.
Yes, we got
No
it.
peer pressure allowed. Anything else on the checklist?
We look for something called homoscedasticity.
Homoscedasticity.
Yeah.
That's a mouthful.
It is a mouthful. Essentially, it means making sure the spread of the data points is relatively consistent across the range of our independent variable.
Okay, so if we were looking at our data on a graph, we'd want to see an even spread of the data points and not all clumped together in one spot.
Exactly.
Got it. Anything else?
Last but not least, we want our residuals, which are the differences between the actual and predicted values, to be normally distributed.
So we're aiming for that nice bell curve shape.
Yeah, exactly.
These data checks sound like some serious detective work, making sure everything is crystal clear.
You got it.
So once we're confident our data is squeaky clean, what's next on our simple regression adventure?
Yeah, it's like once we've got all our ducks in a row with the data, we can really start digging into things.
Okay, so what happens next? What kind of cool stuff can we learn?
Well, we get to look at something called the p-value.
The p-value, okay.
And that tells us if the relationship we're seeing, between the distance traveled and the money spent is actually meaningful.
Meaningful, so it's not just random.
Exactly. It tells us if there's likely a real relationship and not just a fluke.
Okay, I'm following you.
So think of it like flipping a coin 100 times.
Okay, I can do that.
If you get heads 50 times and tails 50 times, well, that's pretty much what we'd expect, right?
Yeah, makes sense.
But if you flip that coin and get heads like 80 times and only 20 tails, you'd probably be like, hold on, something's up with this coin.
Yeah, totally.
That's kind of like what a low p-value does. It's like that 80-20 coin flip. It makes us go, something else might be going on here.
So if we've got a low p-value, it means our travel company might be onto something with this distance spending idea.
Yeah, exactly. It means that connection is probably for real. And when that happens, when the p-value is statistically significant, we get to dive even deeper.
Even deeper. So there's more.
Oh yeah, there's always more to uncover.
I like it. All right, what's next?
We look at something called the regression coefficient.
Okay, the regression what now?
The regression coefficient. It's a mouthful, but it's super useful because
Yeah.
it tells us the direction and strength of the relationship.
Okay, so like if there's a connection, how strong is that connection, that kind of thing?
Exactly. Let's say, for example, our regression coefficient is 1.5.
1.5. Okay.
That means that for every additional 100 miles traveled, the average trip spending increases by $150.
So someone who travels 200 miles further, we could guess they'd probably spend around $300 more.
You got it.
Wow, our travel company would love to know that. They could use that information for so many things.
Absolutely. They could tailor their marketing campaigns, maybe even offer special deals for those longer trips, knowing people are more likely to spend more.
Exactly. Okay, this is great. What else can we find out with this simple regression stuff?
We can also calculate what's called R squared.
R squared, what's that all about?
It's basically a way to see how well our model, in this case distance traveled, explains all those differences we see in trip spending.
Okay, so if R squared is high, it means distance is a really good way to predict how much someone's going to spend on their trip.
You got it. A high R squared would mean that distance traveled is doing a good job of explaining those differences.
Okay, that makes sense.
So, for example, if our travel company found an R squared of 0.8, that would mean that 80% of the differences in spending can be explained just by the distance traveled.
80%, that's huge.
Uh-huh.
They could make some really smart decisions knowing that.
Exactly. They could make way more informed decisions about pricing, about advertising, all sorts of things.
Okay, so we've got the p-value, the regression coefficient, R squared. This is a gold mine of information.
It is. And, while this simple regression gives us a ton of great info, there's always another layer to uncover.
There's more. What do you mean?
Well, let's say our travel company wants to look beyond just distance. What if they want to understand how other factors might influence spending too?
Like what? Give me an example.
Well, like a traveler's age or maybe their income level, even if they booked a last-minute flight, things like that.
Oh, I see what you're saying. So it's like we know distance plays a big role, but what about all these other pieces of the puzzle too?
Yeah,
Yeah, it's like we're trying to put together a big puzzle and we need all the pieces to see the whole picture.
exactly. And that's where we can take things up a notch from simple regression to something called multiple regression analysis.
Multiple regression. What's that?
It's like simple regression, but on a bigger scale.
Okay.
It lets us look at a bunch of different factors, not just one.
So like we could look at distance, age, income all at the same time.
You got it. We can see how all those different pieces work together, which ones have the biggest impact, maybe even how they interact.
Wow, that's amazing.
It's like going from using a magnifying glass to a high-powered microscope.
So we're really getting into the nitty-gritty.
Exactly. It's really cool.
This is pretty incredible. When you think about it, we started with this simple question about travel distance and spending, and now we're talking about all these complex relationships and multiple variables.
That's the beauty of this kind of analysis. It opens up all these new questions, helps us understand things in a deeper way.
I know, it's really making me think about all the different patterns hidden in data that's out there.
It's all about asking the right questions.
Exactly. Well, I want to thank you for joining me today. This has been a fascinating deep dive.
It's been my pleasure.
And for our listeners, I hope this sparked your curiosity and maybe even inspired you to do some data exploration of your own.
There's a whole world of data out there just waiting to be discovered.
And until next time, stay curious.